Hey guys, all right, so this is the continuation of 4.4 notes. Let's start with the minimum average cost. So by definition, if the average cost can be minimized, it will be a production level at which C prime of x equals to C of x over x. Okay, this is an important formula. This is what we're going to be using next. So if you guys remember, C prime of x was the marginal cost. Okay, so C prime of x was the marginal cost, and C of x over x is just the average cost. So what this is saying is that if the average cost can be minimized, then the marginal cost should be the same as the average cost. So let's use this formula right away. Okay, so suppose that C of x equals x to the third minus 20x squared plus 20,000x is the cost of manufacturing x item. Find a production level that will minimize average cost of making x item. So if you can minimize average cost, then this is the formula that we're going to try to do. So the marginal cost equals the average cost. Okay, if again you can minimize the average cost at all, so what I need to do is I need to find the derivative. So C prime is 3x squared minus 40x plus 20,000 equals the average cost is, I'm just going to divide each and every term by x. So here we go. I'm going to take C of x, which is x to the third, minus 20x squared plus 20,000. And then the whole thing is divided by x. Okay, so let's go a little bit further. So 3x squared minus 40x. I'm going to try to solve for x here. Equals to, if I divide everything by x on this side, I'm going to end up with an x squared minus 20x and then plus 20,000. Okay, because I have 20,000 on both sides, so these two guys can totally be gone. I'm going to try to solve for x. I'm going to try to move this guy over. Okay, minus x squared over. At the same time, move this guy over because I want to set it equal to 0. So with that said, this is now 2x squared minus 20x equals to 0. Let's factor out a 2 and then an x. So you are left with an x minus 10 equals to 0. That means x can be 0 or x can be 10. Obviously, you're trying to make things, so to make 0 things is not gonna work because you can't really do an average cost of 0 items, so you can ignore 0. So right now, your how many items you can produce is 10. Okay, now let's try to see if this is something that you can minimize. So what your next task is, you're gonna try to do, this is your average cost. Okay, we're gonna try to do the derivative of this, okay, to see what happens. So the derivative of this, remember, this is what you have for C of x over x. Okay, so this is C of x over x right there. Okay, again, that's C of x over x right there. So if I take the average cost and I do first derivative, how about we just write the average cost first? X squared minus 20x plus 20,000. This is the average cost equation divided by x, and I want to do x prime. So this is going to give me what? 2x minus 20. Okay, I want to find the critical point. So my critical point is going to be x equals 10. Okay, whoa, those two things match up, right? So they both x is equal to 10. Now I want to know if this is a min or max. Now I want to remind you a little bit. Okay, I'm about to do second derivative right now of the average cost, but I want to remind you of this theorem, and you should know it because it's going to be so much faster to decide whether it's minimum or max. But let me just go up to the summary. Okay, Remember this summary chart that we wrote at the very end? When you do the first derivative, okay, when you found the first derivative, you know that it's a local min when the second derivative is positive, okay? And it's a local max if the second derivative is negative after you've already solved for the critical point. So that's what I'm going to use. I'm going to do second derivative, and no, you don't have to, but this is an application. It's just so much faster to do the second derivative, especially this is your first derivative, right? So second derivative of average cost. Let me get a different color pen. Here we go. So c of x over x prime prime. My only goal is to see if it's positive or negative. Okay, so the derivative of 2x minus 20 is just 2. So according to that theorem that we had, when the second derivative is positive, okay, when the second derivative is positive, then this value, it's a local min, okay? Then this is a local min, which means the minimum average cost is at 10 items, okay? Or to minimize the average cost is when you produce 10 items. So that's what I'm going to write as my answer. To minimize average cost is to produce 10 items. Okay. All right. So that's what that is. Now let's do this again on B to see if we'll give you a better understanding. Suppose c of x equals x to the third minus 6x squared plus 15x, where x represents thousands of units. Is there a prediction level that minimizes average cost? If so, what is it? So again, I'm going to use the average cost is the same as the marginal cost if we can minimize average cost at all. So I'm going to take x to the third minus 6x squared plus 15x divided by x. So that's the average cost of whatever x you are trying to produce. And we're going to try to solve for x, okay? And so I'm going to do the derivative. The derivative of this 3x squared minus 12x plus 15. Okay, let's try to simplify this from here. This is now x squared minus 6x plus 15. So equals the right side, which is the marginal cost here for x items. Because both sides have 15, so they can cancel. And just like what we did above, I'm going to try to move things so I can solve for x. Minus x squared plus 6x plus 6x. So this is going to, let's see. Now this is 0 equals 2x squared minus 6x. Then I'm going to take out a 2, and 2x really, this is x minus 3. So again, x equals 0 and x equals to 3. Well, again, same thing, right? We can't really produce 0 items, so we are going to ignore 0. When you're talking about producing things, you want to produce more than 0 items, okay? So the domain of production is always greater than 0. You can't produce negative items either. So I'm thinking to minimize average cost, okay, I need to produce 3,000 units, but I need to do the derivative to confirm my answer. So again, I'm going to do the average cost, and I'm going to take the first derivative so that way I can have a critical point to use. Okay. Now from earlier, the c of x divided by x was already simplified right here. Okay. So I'm just going to steal that and then do the derivative of that. Okay. So x squared minus 6x plus 15. I'm going to do the derivative, which leads me to believe is 2x minus 6 and set equals to 0. I want to find my critical points, and again, the critical point comes out to be 3. So far, these two are matching up nicely. Now, I need to know whether this is maximum and minimum, right? So I need to do the second derivative. So let's do the second derivative. Get a different color pen. Second derivative of average cost, okay. Now the first derivative is already here. So the second derivative is just 2, okay? So that tells me, because the second derivative is positive, you're going to have a minimum at x equals to 3, Okay, but this is in thousands of units, so I'm gonna have to use thousands as a unit here. To minimize average cost, X needs to be 3,000 units. To minimize average cost, X need to be 3,000 units. Okay, or you can say the production needs to be at 3,000 units, or you can say to minimize average cost, you can produce 3,000 units. So any one of those items is fine. And this is the end of this recording.